Hello everybody. In this lab, our objective is to observe the settling behavior of flocculent particles and develop design information for a Type 2 sedimentation basin. The flocculated particles are larger and settle quickly. The settling velocity of particles becomes a function of depth. Therefore, the removal of suspended flocculent material is dependent on depth as well as overflow rate. The extent of clarification is determined by particle concentration, size distribution, and the degree of flocculation that occurs. The effects of these variables must be determined by sedimentation tests. The settling column used in these tests should have a diameter of at least 130 to 200 millimeters and a depth of 2.5 to 3 meters, with sample ports installed at intervals of 0.4 meters or less. The sedimentation test is conducted by filling a settling column with a flocculent suspension that is thoroughly mixed prior to the start of the experiment. Mixing is stopped and samples are withdrawn at predetermined time intervals at each depth. Each sample is analyzed for total suspended solids, or TSS, using gravimetric analysis. The percent removal is computed for each sample and is recorded at the proper coordinate in depth and time, similar in concept to a topographic map. Once a sufficient number of points have been plotted, curves representing equal percent removal lines are drawn by interpolation. Please wear all required PPE at all times in the lab. Lab coat, gloves, safety goggles, and with long hair tied back. Each group will be assigned one of 3 sedimentation columns containing 42.6 liters of untreated water sample. A continual stream of air will be passed through the column to ensure that the particles remain suspended. Add 35 milligrams per liter alum, with an initial concentration of 10 grams per liter, first, and then 0.5 milligrams per liter polyelectrolyte, initial concentration of 100 milligrams per liter, to the top of the column while mixing with air. The concentration of aluminum 3 positive will exceed its solubility limits, and aluminum hydroxide will precipitate, forming a dense flocculent suspension. Ensure that the column is uniformly mixed by allowing air to bubble vigorously for 1 minute after the addition, then reduce the airflow and continue mixing gently for a following 5 minutes. At time t equals t0, shut off the air supply and start timing the settling. Collect samples from each of the 5 sample ports immediately after the air is shut off and every 5 minutes thereafter for 20 minutes, i.e. samples collected at T0, T5, T10, T15, and T20. In the early stages, withdraw approximately 25 milliliters of sample from each port. As the floc thickens in the lower ports and the water clears in the upper ports, smaller and larger samples may be required respectively. Prepare a table in your notebook, similar to Table 1 from the lab handout. For each sample, place a clean, pre-weighed, initial weight equals Wi, Gooch crucible in the vacuum filtration manifold. Record the crucible ID and the sample ID number. Mix each sample to ensure that the particles are suspended. Pour the entire sample into a 50 milliliter graduated cylinder and record the exact volume. Then quickly pour the sample through the Gooch crucible and open the valve to apply the vacuum. Rinse the original beaker and graduated cylinder with a few milliliters of DI water and pour the rinse water through the same Gooch crucible. This should ensure that all TSS particulate from the sample are captured on the filter. Turn off the valve to relieve vacuum pressure and remove the Gooch crucible. Once filtration of all the samples is complete, transfer the Gooch crucibles to the oven for drying at 105 degrees Celsius for overnight. Remove the crucibles from the oven and move them to the desiccators to allow them to cool to ambient temperature for 20 minutes before determining the final weight, or WF. Note that for this lab, the initial weight and final weight of the Gooch crucibles will be determined by the technicians, and the results will typically be emailed to the students the following day. Calculate the TSS as follows. Calculate the percent TSS removal for each sample analyzed. Plot the percent removal on a graph of depth in meters versus time in minutes. Identify each point by recording the actual value on the graph, and draw lines of equal removal by interpolation. Be careful of water on the floor. Walk slowly while in the lab. Do not put pressure on the valves while sampling. The connection between the sample ports and the settling column is rather weak, and the valves can be sheared easily. After this lab, you should know how to use the settlement column to study the settling behavior of flocculent particles and develop design information for a Type 2 sedimentation basin.